Hello and welcome to the this afternoon of September RSE to presentation session 9. I believe this is the last of the large presentation sessions that we have of September RSE. Crumbs, the time has gone by really quickly. So we have 3 amazing talks for you this afternoon. Just as a reminder, everything is being recorded and we put onto YouTube, and we'll have a 5-minute break just after the second talk, so we don't keep you for more than an hour. But first up, we have Talk T1003, How Hard Can It Be to Add a Button, Managing Customer Expectations in Research Software Projects by Matthew Manchin from the University of Manchester. I'll hand straight over to you.
Thanks very much, Chris. I will start my screen sharing. Okay. Okay, welcome to this talk. How hard can it be to add a button, managing customer expectations in research software projects? So let me first briefly introduce myself. So I'm Matt Machin, and I'm Digital Health Technical Lead based in as an embedded RSE team leader in the University of Manchester. And in terms of my background, I've worked in software engineering for over 20 years with a roughly equal split, with the first half being in industry and the second half being in an academic environment. And I've held a range of different roles in that time, from being a software developer through to doing some project management and some team leadership. And my current role, I co-lead a team of 13 RSEs, project managers, and user interface, user experience specialists. And we develop apps for a range of different health-related research projects. So moving on to the topic of today's talk. And this really just gives a sort of perspective of what the problem is really about. So from the point of view of the customer, their view is, well, it's only a button. Surely it can't be that difficult to add. And from the developer's perspective is, well, I've got to design this, add the button, all the functionality. I might need to refactor the code. I probably need to add some tests. I've got documentation to update. Might need to do some regression tests to make sure that nothing's gone wrong, etc., etc. So it's quite easy to see how there's a very big difference between the way that the customer might view these things and the way that the developer views it. And in terms of what I'm going to talk about today, I'll take a closer look at the problem. I'll talk a little bit about the similarities and differences between research and commercial projects, bearing in mind that my experience with commercial projects is from a fair few years ago, but I think that probably most of this still holds true. And then I'll talk through some potential solutions. And I should probably say up front that these are just my views of solutions, and it'll be really interesting afterwards to hear other people's ideas about how we can better do things like this. So how does the problem come about? I want to talk about this from 2 perspectives. First of all, from the customer's perspective. So the customer knows what they want. They've got a vision for what they want to do, or at least they think they have. But in reality, what happens is that they have some ideas to start with, and then what they want changes over time. Sometimes it changes a little bit, and sometimes it changes quite a lot. They also lack an understanding of what's involved in creating the software. So most customers that we work with are not software engineers by background. They don't understand the complexity of some of the software. They often have a fixed amount of time and budget, and therefore you can't easily go to them and say, oh, can you give me twice as much money to do what you want? And their expectations, because of this lack of understanding of what's involved and a focus on their vision, their expectations often exceed what is realistically achievable given the time and budget that's available. From a developer perspective, the developer generally has a really good understanding of the work that's involved, because assuming they've got some experience in software, it's not their first project, they know what all of the tasks that they need to complete, and where the hard bits of the software are likely to be and where the more straightforward parts are. But some challenges come about because maybe they don't communicate this sufficiently clearly to the customer, or they think they do, but the customer doesn't fully understand that because of the language and understanding differences. It can be difficult to get a true vision of what the customer really needs. So the customer might explain what they want, but actually, translating from what's in their head to reality can be quite difficult. And inevitably, throughout the project, it might seem that things are going really well, but then there'll be some technical difficulties that might delay the work, or mean that something that was originally planned to be implemented is no longer feasible, or is only feasible in an excessive amount of time and effort. So it's no longer realistic. I'm going to talk just a little bit about research and commercial projects. So some of the things that in my view, again, this is my view, and it'd be interesting to hear others' views, are similar between research and commercial projects. Customers often have unrealistic expectations. They've got a certain amount of time and money, and they think they can get something rather more than what's actually achievable. Time and budget in many projects are fixed. I would agree. I accept that there are occasions when that isn't the case, but I think that often in most projects, whether you're in research or commercial, there is some kind of constraint over the time and budget. Requirements change over time. I can't recall working on any project either in industry or in academia where the requirements that were set out at the start of the project remained constant to the very end. Inevitably things change because people's views of what they want change as they start to see things being built. And the lack of understanding of what's involved in creating the software, I think, is common. So unless you are working with somebody as a customer who's got previous experience in software engineering, they might understand some of what's needed, but they probably don't understand quite a lot. In terms of the differences, I would say one of the key differences, having worked with a number of academics, and I've got some fantastic academic colleagues, is that they're very good at generating ideas. So academics are very much ideas-focused people. And one of the things about that is it can often lead, therefore, to more requirements. So the list of what they would like is often, in my experience, rather larger than what can be achieved compared with what you might see in industry. So they generated loads and loads of ideas, some fantastic stuff, but then they've got 50 things they want. There's only enough budget to do 5 or 10 of those. I would also say, and again, this is only my own experience, that requirements change more. So it's more likely that you'll have a more significant change of direction in an academic environment. And that might be because the project changes or the academics' ideas change. I think in industry, if you're working in an environment where you're developing a particular product, then the requirements do change, but maybe not to the same degree as you see in academia. In terms of deliverables, one of the challenges that I've faced, and I expect others have too, is that sometimes a grant application will be submitted within which some deliverables are defined, and there has been sometimes, but hopefully not too often, none, perhaps more realistically, not enough RSE input to those deliverables. So the research team will come up with a set of deliverables that they think are realistically achievable. They'll go for a particular amount of budget to do that in the grant application. And then as an RSE or RSE team, you get to look at that, and actually sometimes you find that the budget and time that's available just doesn't align with what is expected in terms of deliverables. And I think the final point here is that it depends where you work in industry, but if you're working in an industry where a particular product or group of products is being developed, then the projects are at least somewhat similar. In academia, you can end up with very diverse projects working across all sorts of different spaces. And although, I work mostly in healthcare, we still have a really wide range of projects there. If you're working across healthcare, engineering, humanities, and all other areas, you probably find some very diverse projects. And that, I think, is an important difference between in academia and industry, and create some interesting challenges. So now I'm going to talk through a few potential solutions. And again, these are my views of what's worked for me, and I'd be really interested to hear other people's views on some of these things afterwards. So the customer has a vision for what they want. That's a good thing, but the challenge comes in translating that vision into what the developer can understand, and the developer producing something that actually aligns with the customer's vision. And there's a common theme that I'll probably say several times during this talk, and that is sharing software early and frequently. If you want the customer to get a better understanding of what their software is ultimately going to look like, showing it to them as early as possible is a good thing, because then it will help to refine their vision rather than leaving it till really late in the day and then they say, oh no, that wasn't what I had in mind. Working really closely with the customer, whether that's a single PI or an entire research team, to refine and prioritize the requirements is really important. And that's something that should be happening throughout the project, not just at the beginning. And help the customer to get involved in choosing between different options. So if they've got a particular feature they want to have, or group of features, and you can see different ways of doing that, rather than just deciding it for them and going ahead, it can be really useful to get the customer involved in that, show them different options, explain the different effort that will be involved in different options, and enable them to be involved and buy into that decision-making process. Being open about what is and isn't realistic is really important. It's much better to say to the research team, actually what you've asked for there it just isn't going to be achievable, rather than going into the project for 6 months and then them realizing that actually you're just not going to be able to deliver within a reasonable time frame. And then I think this last point I would say is particularly important and probably applies to many of the problems here. Listen a lot, let the customer do the talking, but then ask some relevant questions. So try and really get to understand what it is that they want to achieve with their project and the software. Moving on to the next problem. So what they want changes over time. This is going to happen, and there's no way that you can block that. I have worked in projects previously, mostly in industry, where there was an effort to nail down the requirements at the very beginning and not allow them to change. That's just not realistic. In the real world, the requirements will change, and accepting that is important. And where possible, try and be agile so that you can respond to those changes. And again, coming back to that previous point, share the software early and frequently so that the customer gets to see what's there, and that helps to inform the future developments. And then moving on to the next problem. So a lack of understanding. Most of the people certainly that I work with, and I guess this is the same for many of you, do not have a software background. They don't really have much of an idea at all about what's involved in creating software. And that can create a challenge because it means there's a different understanding between the RSEs and the research team. I would actually suggest sharing some basic information about the process. They don't need to know the details of what goes on, but helping them to understand that, there's more to it than just sitting at the computer and hacking code. There's design activities, there's testing, documentation, and just getting them to understand that actually there's a lot more to it than just adding a button. Building trust. I think one of the best ways of building trust is to successfully deliver on previous projects, but also, sharing software early here is good, because if they can see that you're developing something that they like and works well, then that will help to build the trust. And where appropriate, bring them into the process, particularly around requirements discussions and where there are choices about solutions. And then finally, being really open about where you think the biggest challenges and hardest work are. So if they've got a list of 10 requirements and you think that 2 of those are the ones that are going to be the most challenging, be open about that so that they know that when you get to those parts of the work that, things might change and there might be some issues to talk about. And now I've got a couple of slides that aren't focused on specific problems, but are more general approaches. And these are some of the things that I found that have worked when working with research teams over the last 10 years or so. So using an accessible language, by that I really mean don't go into in-depth technical speak, because most of the people that at least certainly I work with, and probably many of you, will not understand that, and it will just cause confusion. I think there needs to be a compromise on both sides. So you need to recognize that they're working in one field and you're working in a very different field, and you should be trying to come together to some extent. But I would say that it's the job of the RSE or RSE team to try and make the biggest effort to bridge that gap. So trying to understand something about their domain. Being flexible, requirements are going to change, what the customer wants is going to change. But at the same time being realistic. So don't be so flexible that if they say, oh no, we need to throw all that software you spent the last 12 months on away and do something completely different. Be open with them about what the implications of that, and try and be realistic about what can actually be achieved. The next point I've kind of touched on already, which is about being open. Inevitably, at some point during the development of any complex piece of software, something is going to go wrong, which might have time or budget implications, or may even risk jeopardizing the project. Whilst the research team don't need to know every little detail of what's going on in the software development, if there's something serious, I would always, because it's much better that they know early, and you can discuss as a team a way forward, rather than you hiding it for 6 months when they're about to go to the most critical part of the project, and then you say, oh no, actually this isn't ready. And then the final thing on this slide is being comfortable about saying no, but being able to back that up with strong reasons. So sometimes the research team will come along and say they want to do X, Y, and Z, and that just isn't achievable within the time and budget. And at those points, it's important to just say no, and to be really clear about that, but to explain clearly why that's not achievable. Some of the other things that I've found worked is holding some sort of review or retrospective meeting with the customers or with the research team. And this could be at the very end of the project or at the end of a significant delivery. I found that I've learned things about how they view what's gone on, and how their views can differ from the views I might have or members of my team might have. And having these kind of meetings has been really helpful, and it draws out the good things as well as the things that could have been better. Be committed to building a relationship with your customer, and accept that this will take a long time. So there are people who I've worked with for many years, and I'm still learning about better ways to work with them and how to deal with particular challenges. And I know, for instance, some of them will say they don't like it when I say no, even though they understand why, they still don't like it. And that's people who I've worked with for 8 or 10 years. So it takes time to build a relationship and to build that trust and to try and understand each other's perspectives. But it's well worth investing the time into doing that, because it can reap rewards in terms of successful projects. And again, then coming back to the point I've made a few times already, which is to deliver great software early and regularly. So they get to see what you're doing, it builds the trust, and they can also give feedback and help to steer where to go in future. So to bring this to a conclusion, how hard can it be to add a button? I think the answer to that, as we all know, is that some cases it's very hard, in other cases less so. I would say that the real challenge is not adding the button, but reaching a shared understanding with your customer of how hard it is. So I'm going to finish now, and we can go to the Slido questions. My email's there if anyone wants to contact me afterwards. Also, please use the Slack channel, SeptembRSE, where I'll be around after the talk. And I'll also try and drop into Gallertown as well, in case anyone wants to catch up with me there. Thanks for listening.
I'd say thank you very much, Matt. That was a really brilliant talk. I completely, echo what you're saying about trust, openness, and share early, share often code. Definitely don't work on a project for a year and then deliver something in the last week. That's quite a poor idea. Anyway, we've had some questions coming in. Remember, the link is in the chat for the Slido link. I'm operating this at the same time. So we'll start off with the top question, which is customer client the right model of interaction between RSEs and researchers? Should researchers be involved in software development too?
That's a really good question. And I think I would say the model depends on the environment in which you're working. So for me, the people that I work with are typically clinicians rather than other. So they're research clinicians, but they're not people who would otherwise write code or do anything like that. So they're not engineering focused. So I think for us, there's an element of customer and there's an element of collaborator in terms of the relationship. So I think we do both. It wouldn't be appropriate for them to be involved in the software development other than in the aspects of the process that I said earlier, things like requirements and decision making on the priorities. That said, if you're working in a more engineering environment or maybe computer science or something like that, where potentially you've got people who've got some kind of background that's software related, then potentially you could bring them more closely into the process and they could actually be doing part of the software and there might be some knowledge sharing across both ways. So you could help to improve their software engineering and they could help you with other skills.
Thank you very much. That was a very good answer to the question. So we'll move on to the second one. Do you find that academics' requirements grow once they've seen the initial early version of the software, like they suddenly see what's possible and their eyes grow?
Another great question. And I would say this can work both ways. I've seen academics come with a massive list of requirements up front before we've ever even started. And I have also seen that what's suggested here, new ideas coming once they see something. I think it can work both ways. Maybe sometimes when they see what you've done, even if they're really happy with it, they might then start to appreciate how much work's involved in some of these things. And that might help to control their ideas. But it can also work, the question's right here, that it can also work the other way, that they see something, they think, isn't that fantastic? Can I have 10 more of those and all of these other 28 things as well?
Right. The next one is more just a comment, which I think is very useful. So I find it useful to create a glossary of terms between you and the customer. Some technical words have totally different meanings in different domains. Do you want to comment on that?
Yeah, I completely agree with that. And that's one of the things actually that we've increasingly doing in a number of our projects where we're trying to take a team science approach. And yeah, a glossary of terms to bridge that language barrier is really important, because something like the term model could mean a very different thing to a data scientist compared with a software engineer.
Well, I think I'll do this one next. Could the project funding model be improved? At the moment, the budget timescale is effectively locked in from the start of the project, though I would say possibly that's also true in industry as well.
Yeah, it would be interesting to know whether the funders have any views on this. I sense a general reluctance to go back to the funder and say, oh, we've realized something in this project, we need more money. It does happen if there's a big change happens, but in general, there's a reluctance to do that. But locking in the budget and time scale, maybe 3 or 5 years before delivery is problematic. And it would be interesting to know whether there are options of changing that in future. It seems to happen very little in my experience. And I think you're right, Chris, that there is an issue in industry too.
I think I agree with you.
Somebody somewhere has to pay, and there isn't a bottomless pit of money.
Exactly. I think more awareness of project management and managing the project time scale of time, resource, money effectively would be, or features would be, I think, a useful thing. And I think you're right, having more flexible ways of funding. So instead of giving 3 years of software development, but potentially it's on a rolling 3 month by 3 month, but much more flexibly given based on deliverable of requirements. That might be a way forward. But anyway, thank you very much for the talk. That was extremely interesting. I enjoyed that a lot. 2 more talks to reach my highlight of the day, but your one's riding high. So I think we'll move now on to the second talk of this session, which is for Naeem, and that's on impact of RSE's collaboration with researchers, refactoring, statistical R packages, case study. I'll hand over to you, Naeem.
Thank you so much, Chris. I do apologize, there is a construction noise out there, but I activated the suppressor for noise. I hope everything goes well. Hi, my name is Naeem, and this talk is a case study what Matt mentioned in the previous talk. It's about refactoring statistical R package. I'm a research software engineer at Mahmoud's team at Harvard University, FAS research computing team. Harvard has a FAS research computing organization, has a couple of teams. One of them is research software engineering, and I'm part of that team. We are working on an R package that is called Causal GPS, and the package, we are working with biostatisticians and environmental health specialists, epidemiologists on developing this package. The package is conducting causal inference in the context of observational studies. And the idea is answering the question, what would have happened if, for example, if I had stopped smoking 5 years ago. And the goal of the project is to have standard open source software optimized, well designed to use all available computational resources. Similar to many RSE projects, it's an interdisciplinary project. We need to know domain knowledge, which in this case is causal inference. We need to know cloud computing, big data problems, HPC, and software engineering. So it's obviously research software engineers cannot be on top of everything, but you need to have enough knowledge about these topics to be able to ask good questions from team and to understand what can be done. There are different approaches to solve the problem. One of the, in this case, I'm mentioning 3 of them. And as I mentioned, it's the R package. One part of that is related to package development itself. The first one is making sure that the package is following software development lifecycle. It includes adding unit testing, continuous integration, version control system, logger, also adding documentation. And mostly this documentation is for developers, how to contribute to the project, how to report bugs, how to request new features, and so on. The second step can be improving package related and language related requirements. And if you want to submit a package, which is in this case, it's R to CRAN, it will be, you need to follow those restrictions too. And finally, you need to be effectively use computational resources. And this includes efficient implementation, using multiple cores, having control on third-party packages, and understanding the language features, which I will talk about that in the next slides. One of the important part is following modular approach. In this case, mostly researchers, especially who are developing R packages, are trying to write nested functions. It makes it very difficult to test it and understand or improve it and understand what's happening. So we managed to improve this part with breaking down the code into smaller functions, writing unit tests, So we added unit tests at different levels, checking the size of data, format of data, see if it raises the error that we expected, and so on. And also we added continuous integration to the project, which improves when they are automatically want to add new code, it tests all these unit tests for them. The other part is adding documentation for developers. This is very important. If you want to contribute to a scientific research, you need to read papers, you need to understand the internal documentation. And in the paper, most of the time, the details are not there. As a result, developer guide is very important. We added developers guide that helps anyone who wants to contribute to the projects understand where to start, how they can work on the project. Also, we have functional testing. In functional testing, if there's a developer who wants to contribute to the project, but beyond the level of just function, they want to redesign the package, the functional testing helps a lot in understanding the big picture of the project. Also, we added flowcharts, algorithms at the GitHub wiki page. And in this case, you can take a look at the flowcharts and understand easily what's happening inside the code. The other feature from best practices for software engineering is Git branching model. We are using a standard Git branching model, but so obviously all software engineers are using a Git branching model, but it's important to talk with researchers and make sure that they also understand what does this mean. If we had a couple of training, and now researchers know if they want to use the most updated version, they need to install it from develop branch. And if they want to share the code and be a little conservative about bugs with other people, they need to share the master branch. And the features branch, when they want to add new features, they can use features branch. After polishing the code and package from a software engineering perspective, we take a look at the code internally and see the numerical analysis and see how we can improve it. If you can get algorithm from researchers, that would be great. But if you cannot get it, you need to take a look at the code and understand what's happening internally. So there are many examples of improvement, but here I'm showing a couple of them. There are some parts that is CPU bound. There are some parts that's repeating the same process in a loop that is not necessary. And also there are, at some point, they are making very large matrix that makes it very hard on memory and causes out of memory errors. So in this case, we are, for the first part, we parallelize it. For the second part, obviously, we put the repeating part out of the for loop. And for the third part, I rewrote it in C++ and use RCPP to combine it with the package. And also, I use OpenMP to make it efficient. Another place that you can take a look is having control on the third-party packages. So you should not make assumption that when they are using other packages, they are using their packages in full capacity. This is an example that they were using XGBoost inside Superlearner, and the default value was for using multiple cores was 1. So we added new wrapper to make it much more efficient. Another feature is understanding the R language itself and what you can do about that. I have reviewed some codes in R, and most of the time people use reduce for binding lists, especially nested lists. And as you can see, there's a huge difference with reduce, and the other alternative is do call. And in this example, it can improve the results by 1,000 times. Which you can work on that too to improve the package. We also added a package website using package down package, and also we submitted the package to CRAN, and people are using the package right now. In summary, we contributed from two different aspects. First one is from user side, we added different values, and from developer side, mostly our work was for developer side to make sure that the future development will be smooth and easier. And there are some ongoing activity too. We need to handle big data problem, cloud readiness, and also preparing software for preparing software manuscript for publication. The one step that is missing is conducting large-scale verification and validation. It's very important because researchers are not using the code that much. They are using specifically for the input parameters that they have, but we need to do more testing on the package. And this is great opportunity for internship. There are some tasks that's important but takes time. And on the other hand, there are some students, they want to learn doing research and software engineering. So code profiling, verifying the code with other implementation if it is available, improving code coverage, enhancing unit and functional testing, and addressing pending issues, enhancing log messages are topics that interns can work on. And from this process, interns will be familiar with version control system if they are not, implement the code and contribution to the project, have hands-on experience with graduate level research, and also working with HPC system, and possibly considering RSE as an option for future career. So these are technical details about the project, but there are many challenges, as Matt mentioned, and learn lessons, but not necessarily all learned lessons here are related to this project. So I have been lucky enough to have full support from researchers and my manager at FSRC, but these are points that can happen. One of the challenges is where is a good place to stop, and there are differences between minimum requirements and ideal software. Most of the time, researchers they might not know what can be done, and it is the responsibility of RSE to be clear about that and explain what can be done about that. But even if you cannot do that, probably you can implement infrastructure at some point for easier tasks. For example, if you want to add a logger in R, you need to do some housekeeping for adding logger, but writing log message, maybe you don't want to write a log message for everything. The researchers can do it for themselves. And also using placeholders are very important. For example, let's say you want to read one specific data format. For the other data format, you can put a placeholders. User can use it as an input. But when they are asking for that input data format, the program will print out that it has not been implemented and gracefully close the program. So in that case, the researchers can see what can be done if they want to contribute more to the project. The other challenge is managing expectations and building effective communication. Expectations are very high, and you should be able to manage it. As Matt mentioned, the agile software development process is the best way to do. Sometimes it's tempting to do waterfall development, do everything, and at the end of the project deliver the product, but it's very risky. So you need to help them to visualize the final product, although it's not fully completed. And using placeholders is very effective in this case. Building effective communication also is very important. Researchers are not professional software engineers, engineering hiring managers. They might not have good idea what to expect from technical point of view. And for example, they might think, okay, optimizing the code, parallelizing, there's one way to do that, and you should be able to do that in a quick time. But in reality, there are many ways, and you should double check everything. Special technology is growing, and each year there are new technology with different requirements. So it takes time to find the best solution for the problem. and you should be open with the researchers about that and help them to understand the process is not that easy. And sometimes I found taking snapshots and sharing with researchers can be very helpful. They can see what's going on, and when they are choosing different input parameters, what internally has happened. Another learned lesson is making assumptions, and we should not make assumptions. And it's very easy to make assumptions because it's common sense. We always tend to think about the worst case scenario. For example, here they say, I ran the code by 10 cores before starting the project. I ran the code by 10 cores and about 20 gigabytes of memory in 5 hours. So you quickly assume that the code that they mean in that sentence is the one that they share with you. And they ran the code on the current system. If they are using university HPC, they meant university HPC system, and the numbers are exact or very close. But other possibilities are there's almost always a different version of the code in the research lab, and they may be using another version. So you should not make assumption about that. And also about claiming that they uses 20 gigabyte of memory. In reality, they may use 150 gigabyte of memory because the node, some nodes have 500 gigabytes in it, and you may use the RAM on the system. But if you assume that it was 20 and they assume that it was 20, and you bring 150 to 60 gigabyte, they won't see any progress on that, and also they may think it's not progress at all. So a better approach for this could be, please share the code with me and let me know how I can get the same results. Another example could be, I want to be able to run this code on HPC. So you think, you assume at first that the code runs on local computer, and on local computer it provides the results that is acceptable results. And on HPC they want to run with the same data format. But the other possibility could be the code may need to pass verification and validation tests before scaling out. So if you scale it out and they don't like the results, it's very difficult to understand where is the problem. So a better approach could be, please show me the code works on local system and let's agree on outputs, or are you going to use exact, or are you going to use exact input data, exact input data, and does the data format remain the same? So as Matt mentioned, you need to ask open-ended questions and let them talk about the requirements. Another option is, I want to make the code faster, and you hear this a lot. So your assumption is the code is slow. The problem is algorithmic design or using computational resources, and the researchers totally understand how much the code is slow. But the other possibility is researchers may think their code is fast and amazing because they want to make it faster. So it's already fast. They want to make it faster, but it requires much more contribution and this contribution than simple fixing and optimizing the code here and there. So a better approach for this scenario could be, please explain why do you think your code is not fast enough. So they can explain their reason, or if you ask the question, they say, no, it is fast. I just want to add these features and that. And the final example in this case is, they say, I want to convert the code base into a standard software. But you assume they know what's the standard software and what they should expect out of the project, but they may have completely different expectation than yours. So you can talk about the standard software and see if they have good expectation about that. Yes, one more example is, I tried to run the code, but I received an error. So in this case, we try to assume that they use the most updated version of the code. They use appropriate input parameters. They search about the error message, and they are confident that the error is related to the package. But the other possibility here is they might use use older version of the code, or at some point they are using another code. It happens all the time because there are many versions of the code at the research lab if they are sharing the research space. And also the error is not related to the package. So you can ask which version of the code did you use, or what's error message, and so on. The other lesson is organizing benchmark studies. Most of the time, PIs of the project will not run the software directly, and students will do it. And students most of the time do not read the documentation, and they also make assumptions. So it's good to have a couple of data sets before starting the project. Small data sets can be used inside examples, inside the package for examples. Medium-sized data sets can be used for challenging personal computer, and also big data set can be used for challenging HPC systems. So you may hear these statements frequently. For example, I could not install the package because we are submitting this package to CRAN, and thanks to our hub, we know that we can install package on Windows, on Mac, on different flavors of Linux and other systems. So it's not a problem. We have we receive email about that it was successful. So whenever they mention I couldn't install it on Mac, and PI say, okay, what happened? Why they cannot install it on Mac? You can say, no, we can install it on Mac. The problem should be another things. They may say the code works with a small data set, but I could not run it with larger data set. And again, if you have good benchmark studies, you can show that, okay, we have run it and it works well. And code working with different data format. If you have enough placeholders and catch bugs, catch errors, it should not happen. They can come up with the error message that's very informative. And also why the result of X is not equal to Y. This is also depends on how much you have interaction with the researchers on doing the research and running the data. There are some other notes that didn't fit in that category. Research software mostly is designed based on ideas that have not been fully tested before. Sometimes it might work, sometimes you may get some other results. So in that case, you don't know who to blame. If there's a bug in the system, or if the methodology has a problem. So it can be challenging at some point. It's good to create tangible measures for before and after the project. And I think you should always keep the old function, because there might be a better option, and there might be a better option and you can use it. But most of the time, researchers may think their old implementation were better. And in that case, they can directly use their old implementation to see if it was better or not. And also it is very handy for debugging purposes. For example, in reproducing previous results or the current results, if you want to make sure that the new implementation is not breaking any scientific path inside the code, you can use the older implementation to do the testing. And also,
I've got to interrupt now because we need to have a little bit of time for questions, if that's okay.
Yeah. Yeah, this is the final slide. The funding was provided by NIH grant, and I'm so grateful for that. Thank you so much. I open for the questions.
Cool. So we have had some questions. That was a fantastic talk, I would say. I feel I recognized a lot in that. I think I'm going to make all of my group watch that, because there were lots of things in the consult part that really resonated. So I'm going to start with the top question here, which is the R community appeared to be far ahead in adopting software engineering best practice. Is this what you see too? And why do you think this is the case?
Yeah, for packaging side, I really like the community convention, but for some other steps, maybe it's not that much. I think it's not. There's no that much convention among our developers. There are many packages for example, for implementing Logger. But I think for package perspective, it's great. Yeah, I really like RHub and CRAN support.
Cool. Okay, we'll move on to the next question. So do you have any problems moving researchers to using feature branches? I think this referred to when you're looking at the Git branching at the beginning.
Yeah.
Do you find that they want to create their own user branch and just stick to that?
Yes, it happens all the time with researchers, but fortunately, the team that I'm working, they are very professional, and right now they are using different feature branches, different master branch and develop branch, and they could adapt the situation very well.
Cool. Okay, we'll move on to the next one then. So great presentation. I completely agree. It's a brilliant presentation. Did you use any specific project management tools, and are researchers using those tools as well?
We are using Slack and Basecamp for communication, and Asana for management. But I think the best place for managing features and feature requests is GitHub issue. That helps a lot to find out why did you choose this, and if it's done or not, or if someone else wants to work on the issue, it will be very easier to manage from that time.
Well, I think this last one is more of a comment than a question, but they're saying, just agreeing that I also see that researchers are always using an older version of the code. They don't like upgrading. I've experienced that as well. Causes big problems with bug fixing. I think what I'll say, to make this a question, what would you do to try and encourage researchers to get into the habit of always updating the code and being on the latest version?
So what we are doing, we share the code in we share the code that they are using. Let's say they are processing in a private GitHub account, and I always can follow which code they are using. And when you are installing our package, you can install it even from a hash commit value. So I think we don't have this problem right now. We had this problem, but now everyone knows there's updated package, and also they update their own personal version frequently.
Cool, thank you very much. And I also saw in the chat, there's a comment from Hugo who said, I would say good practices, I think in the R community, are well adopted because of very good documentation exists on that topic. Yeah, I think I would also agree with that as well. Okay, so thank you very much for your talk. We're now going to have a 5-minute break. And after the 5-minute break, we're going to have Senior Level RSE Career Paths with an S by Dan Katz. But please enjoy your break now, and I'll see you in 5 minutes.
Thank you.
Okay, welcome back. I hope you had a very nice short coffee break, comfort break, etc. So we have our third and final talk now. This is with Dan Katz, who's joining us from the US at 9 o'clock in the morning. So thank you for joining us so early. This is Senior Level RSE Career Paths with an S. Over to you, Dan.
Okay, great. Thanks, Chris. Yeah, so I'm going to try to talk for not so long and leave some time for questions. So I hope there are some questions. I also, for the first time, I think for a slide, for a talk, shared the talk as well as a blog about the talk yesterday. And so I was a little bit actually kind of wondering how this was going to work, if people were going to like this or dislike it, or think that they've already heard everything because they've read the blog. So I'd be curious about any comments on that as well. Okay, but on to this. So the thing that I want to talk about is senior level RSE career paths. Basically, what happens to RSEs when they get to a senior level? This is work with Kenton McHenry and Zhong Li as well from NCSA. So let's start off by talking about different dimensions under which we can consider RSEs. The first one, I think, is just to talk about time. That we've had 9 years of RSEs, starting with the collaborations workshop in 2012, and having a lot of different activity in RSE organizations, having activity in RSE groups, in particular in the UK at this point, up to about 30 groups right now, having activity in terms of conferences, and in terms of leaders and communication. Right, so there's been a lot of activity in terms of thinking about RSEs and RSE organizations at a collective level over these 9 years. There's also the dimension of thinking about RSEs in terms of their technical work, and this is a slide that Simon has used in the past, and everybody here knows this, but just in the effort of being complete, right, RSEs are sitting somewhere in the middle between software engineering and research, and have software engineering skills that they can apply to research, and they're comfortable in research environments where requirements aren't known ahead of time, and there's a lot of interaction that has to happen in order to figure out what software needs to be built. We can also think about how RSEs fit into groups. And so one option is that we have individual RSEs within groups of researchers. Maybe this is a PI's laboratory. And these different RSEs and these different groups maybe are talking to each other informally. We also can think of an RSE group within an organization, and then members of this RSE group then can collaborate with particular PI groups, but the RSE themselves are sitting within some kind of a larger RSE group. We can also think of when we get to having enough RSEs in a particular institution and a group, that group then needs some structure. And maybe there's a leader of the overall group, maybe there's leaders of teams, and then maybe there are people that work on teams or something like that. But the point is that as things change over time and RSE groups get big, there's some structure that's needed. So having thought about this again, we can think about RSE dimensions in terms of the technical role of the RSE, in terms of their structure with researchers, in terms of their structure with RSEs themselves. The thing that we haven't really talked about is the dimension for an RSE about the structure of their role in their career with time and how their career develops. And so that's what I want to talk about here, some things that we're doing, some suggestions that others maybe would be interested in as well. So to start with, we have the idea that RSEs, as well as everybody else in a professional world, needs career progression. And from the point of view of looking at an institution or thinking of an RSE group leader, we also want a way to try out new RSEs and make sure they can do the job. And something that typically happens in business is that you start off with somebody at a fairly low level, at a basic level, and you say that in some period of time, maybe 2 years, they have to progress past that first level onto the next level. And it's kind of like a trial period in some sense, even though from the HR point of view, it may not formally be a trial period or a probationary period, which may be just something shorter. Another thing is that if we have career paths that have too many levels, it makes it actually hard to distinguish between those levels. And for the group leader or for the person in human resources that has to define the characteristics of each level, this can also be very hard. So let's pick 3 basic levels as something that kind of compromises between these two different goals of wanting to have enough levels and not wanting to have too many levels. And typically, I think these are called something like associate RSE, staff RSE, and senior RSE. Once we have these levels, and these again are something that I think a lot of groups have the equivalent of this, if we're thinking about a lead level as well. The levels as they increase can include some mentoring and leadership. And at some point in the technical progression, the mentoring and leadership really becomes a key characteristic of a person who's progressing. And so let's call this the lead RSE level, and we'll just add it on to the end. So in my opinion, being at this lead RSE level requires the ability to be the PI of a project or to lead an element of a large project. Right? This is not just working with a group of researchers, but this is actually leading something that is in collaboration with that group of researchers. It's possible that you may have to demonstrate that you are doing this in order to be a lead RSE. A lot of people talk about the fact that to be promoted, you need to demonstrate that you're working at that level already. And so that's certainly one way of thinking about this. So once we pass the lead level, then what happens? And what I think happens is that there are a bunch of different emphases that the RSE can look at. And really, these are multiple aspects of leadership. So the RSE may choose to emphasize one aspect and use that emphasis then to build new skills and maybe move into a different role that's not strictly an RSE role. I'm going to say that there's three options. Okay, sorry, this took a second to progress. So one of them is the product manager role, to be product focused. So this is, in addition to all of the RSE work, being able to think about how an overall product is working and even the non-RSE activities that are associated with that product. Another is to stay very focused on RSE work, but move to a level that's even higher than the lead, where you really become an expert and you are called upon to provide your expertise to other RSEs in your organization. And so this is really a technology-focused idea. And the third is to move into something that's more people-focused, to become the group leader, for example, or to move into some other kind of a people management-focused role. So if we think about these RSE roles within an organization, a senior RSE is likely to have aspects of all of these emphases and really aspects of all of these sets of skills. It's also worth mentioning that for these to be formal roles, the organization really has to have sufficient scale. So an organization that has 5 RSEs maybe isn't going to have any of these senior roles defined in this way. But an organization like NCSA or the organization at Reading that Brian Lawrence is tweeting about today, when it gets to a certain size, maybe that's 30, maybe that's 40, 50, I don't know what the right number is, or RSEs, then you start to need to distinguish and to think more structure like this. If you don't have that size, again, a lot of these roles probably are combined. And so group leaders in smaller organizations likely are doing aspects of all of these things. They're managing their group. They're providing RSE expertise and mentoring to others. And they're also thinking about the things that they've built that maybe become products that that group and that university is proud of. So if we think about these three different paths again, there's a question that you can think of, which is what happens after this? If you're a product manager RSE, if you're a principal RSE, if you're a group leader RSE, right? What happens to you after this? Where else can you go? And so my thought is that these are endpoints for RSE career paths, but they're not endpoints for career paths. They're just endpoints for the RSE part of these career paths. So the principal RSE maybe actually maybe stays in that role and continues to work directly with software and mentoring others, leading software projects, things like that. But these also could be the point where somebody might leave the RSE community and change to further grow some other skill or skills. So the product manager RSE may move into some kind of larger product management outside of software. An example of that is in an organization like NCSA, where we have some HPC resources. This person may become the PI of an HPC system. It includes hardware and software and operations and other things. They can take the skills that they've learned as a product manager for software products and think about other products that include software just as one of many components. The group leader RSE could move to become a higher level organization manager. Maybe they become the manager of some part of the IT organization as a whole that includes the RSE group, or even that doesn't include the RSE group, or becomes the IT manager or the CTO or the CIO of a university or an organization. Or in the case of something like NCSA, they could become the center director. In these cases, they may still have some responsibility for software, but it's probably not hands-on work with software. It's more directing the people or the part of the project that is focused on the software. And it's worth also saying that this is really a choice. It has personal and professional aspects and consequences. And so I recognize and completely accept that these are not going to be the right options for everybody. But they're choices I think that we want to offer for people that are interested in taking them. So the last thing that I want to talk about then is how we actually can support these paths. And so I'm going to talk a little bit specifically about what we're doing at NCSA. So I think we need institutional financial support for people in these paths. For people who are RSEs up to the lead level, they're typically 95% project supported and 5% center supported. This 5% is for institutional activities that are not project specific activities, like working on a hiring committee or doing some basic proposal work. By the lead level, these RSEs are acquiring projects by writing parts of proposals and are representing NCSA in discussions with collaborators and funders. And so in those projects and in those activities, they may need additional institutional support, but that support would be dedicated to a specific activity. So they might get an additional 10% to work on a particular proposal for 3 months, for example. RSEs at the group leader RSE level are 20% center supported. And this 20% is primarily for management activities of their group. We don't formally have principal RSEs or product manager RSEs yet, but we imagine that those would be probably 20% center supported as well. We'd be investing in them for their and our future success. And in the case of the product manager, we'd also be investing in some sense in their product. It's worth mentioning that a product manager RSE can also acquire funding for their own product and themselves in a way that a people manager really can't. The last then part of this is also then to talk about institutional intellectual support. Again, talking about what we're doing at NCSA now. This can really be somewhat hard to define, and it's often less formal. We have informal mentoring, and this is mostly embedded within projects, but a little bit embedded within groups as well. This often happens from a senior person identifying opportunities or activities that a junior staff member can use to build new skills. Something like task management, sprint planning, release planning, something like this, again, typically for a project. The senior person then delegates that to the junior staff member and then coaches them in how to make it successful. We don't have very much formal training that's relevant to RSE careers and RSE career growth at this point, but we do want to formalize this, and we've started talking about it. And we're developing some training, and we've used some external programs as well. And so just to mention a couple of these things, we have used external programs in terms of leadership, in terms of proposal development, for task management, and for technical training. And an example of this is an NSF-supported program called Cyber Ambassadors that we've been involved with, and we're becoming more involved with, that encourages training in communications and teamwork and leadership skills and collaboration skills. I also should mention that there really is an organizational intent question that's worth mentioning. I said before that an organization has to have sufficient scale to support these career paths, but it also has to have the desire to support these career paths. And it really has to turn that desire into activity and funding. In a project-based research organization like NCSA, for example, the flexible funding that can be used to support these career paths requires some institutional buy-in, some institutional funding. But these funds are also used and needed for other management and administration and other things. So there has to be a choice made that this is something that's worth doing. On the education and training side, to create these kinds of educational programs and mentoring programs requires having enough participants to make the programs worthwhile. And again, requires the institution to want to invest in people, not just in projects and in software, but to think of the people really as the center that's going to drive the institution forward and make all the other activities successful over time. So just to wrap up, we have today growing acceptance of RSEs over the past 9 years. According to Simon Hetrick, and I have no reason to doubt this, there could be hundreds of thousands of RSEs worldwide. And so it's really time to think now about what happens to these RSEs later in their careers, particularly as we're getting to the point where RSEs do have a later in their career point after 9 years. I've proposed a branching path here that starts with technical skills, then adds leadership, and then potentially moves in different directions, technical project focused and management product and people focused. And these then can lead to even more senior roles within organizations that may have little hands-on RSE work for those who want to go in this direction. And I think this is really our next needed step to define these more senior roles for RSEs to aspire to and to aim to, and to think of this as a step of attracting new RSEs to our organizations by giving them a set of possible futures, both as RSEs and beyond RSEs. And so with that, I will end and see what questions have come in. So thank you very much. Sorry, I should also mention, this is partly based on a blog post from last year that Kenton and I did. A lot of this thinking is based on this book, The Manager's Path, from Camille Fournier, that I think is really worth reading. And as I said, again, then there's a blog post that I wrote, yesterday about this. Okay, thanks very much.
Thank you very much, Dan. That was a very insightful and well considered and well thought through talk, and I can recommend the blog post as well. I think it's like a must read thing for many of the RSE leaders in the country as well. This has created a lot of questions, as you can probably guess. So if it's okay, we'll go through them kind of in order. So the pathway is a pyramid. What happens to RSEs who want to progress, but there are no higher positions available? Should they leave RSE?
So I don't actually see this as tremendously different than almost any other kind of career path, which I think pyramids are very typical in most parts of organizations. Excuse me. So I think there's really two different choices in some sense. One is to wait and to continue making the case for yourself, and as the organization grows, the base grows, the higher levels may also grow, and that then may give you an opportunity, or people retire, people are promoted, people move on. The other option, which I think seems to be more popular in the US than the UK, but is also worth thinking about, is looking at other universities where there are openings. I think from my point of view, the idea of being able to take experience in one organization and bring it to a different organization that has different practices can be tremendously valuable to the person and to the new organization. Although I recognize that that's not something that's possible for everybody based on individual requirements, but if it is, it's something that you should consider as well, I think.
Cool, thank you very much. Okay, so how can we combine academic ambition with the progression of as an RSE?
This is a really good question, and I think it depends a lot on individual conditions and national conditions and university conditions. So in the US, the option that somebody has typically is being in a tenure track position or not being in a tenure track position. And so if you're in a tenure track position, you probably are not an RSE, but you can be bringing in RSE skills, and your progression then is within that tenure track path. If you're in an RSE position, your progression is typically within the RSE career path. But you also can have academic ambitions, and it's certainly becoming more usual for people who are RSEs, at least in some cases, to have some kind of research appointment in a department in a faculty, as I do, or to have some kind of a teaching appointment if that's the thing they're more interested in. And so I guess I tend to think, at least in the US, of those two options as being somewhat unique, but having some overlapping aspects. If the question, though, is not related to career, but academic ambition in terms of more academic recognition, I don't see any issue there at all. I think that's actually very natural to do within an RSE. Right? So an RSE can be writing papers about their projects in addition to producing software. They can be giving talks that are in some sense entrepreneurial or marketing talks about their products that they're working on. They can be giving talks about the model that they have. They can be kind of out recruiting people and trying to grow an RSE group, which in some sense you could think of as a research group. And RSEs also can have their own products, in my opinion, and we do this at NCSA. So we have products like Clouder as a data management system, like Parcel as a workflow system, where we are the lead developers of those products, and we work with lots of faculty and lots of researchers to find users and make sure we're doing things that are useful for them. But we're not the junior partner; we're the senior partner in those cases, and so you really can have both models, I think.
Cool, that was a very good answer. So the next question we have here is there any hope of career progression paths for embedded RSEs, or are groups the only way to have a career as an RSE?
Yeah, so that's another good question that is, I guess I'm kind of probably biased from my group experience, but I think that for embedded RSEs, similar career progression is possible. It's just going to be harder to argue in some sense and to get buy-in for. Because from the point of view of the group, you have a natural affinity in some sense of people and an organization that can go to an HR organization or to the HR part of the organization and say, this is what we would like to do, and we have this set of people and we have this problem. When people are embedded, they're more separated in some sense, and so they have to again have this informal communication or some kind of a group that forms to include the embedded RSEs, where they can talk together and can figure out how to talk to their managers collectively about their needs for career paths. But I think that it's going to be harder when the manager is not focused on their careers to begin with.
Yeah, I think you're right. I think that there possibly could be a route for them doing the product manager route, but they'd be having to build the product effectively themselves. I know where I am, it's very much we view embedded as eventually coming into the main group, because that's a way of enabling them to grow their careers beyond just the projects that they're working on. Okay, so the fourth question, or the next question, some RSEs resist the idea that progression requires taking up leadership or management or mentoring roles. What would you say to those RSEs?
I think you can make that argument, but I think it limits your progression. So in our case, we have, again, there's these three initial levels, and I think if you're not willing to do any leadership or any mentoring or any management here at NCSA, you will end up being kind of in that third level for the rest of your career. And that may be perfectly happy for you. You may be perfectly happy with that, and if so, that's great. So there is some progression, but again, I think the question is not for people that are happy with where things are now, but for people that want to move further. Can we create new opportunities for them to move further again, whether that's within an RSE role or moving outside of an RSE role? So I think, in some sense, you could think of this actually as not necessarily different than a faculty role. Again, kind of using the US example. Somebody may be an assistant professor, then an associate professor, then a full professor, and lots of people are happy being a full professor, and they stop there. But some people want to go on and they want to become a center director or a department chair or a dean or something else. And so it's not that we want to say that that there's something bad about stopping at a particular level, but we want to create opportunities for people that do want to move past those levels and want to try something different at some point in their career.
Cool, thank you very much for that answer. Okay, I think we have the last question here. So at what level, staff, senior, or lead, do you think it's necessary to start heading towards one of the three paths that you identified?
I actually don't think that there's really any answer to this. really, I think, depends on what you want to do. And I think at all of these levels, you can be thinking about all of these different options, and you can bring in aspects of all of these different options. And I think we certainly have people at NCSA and certainly other people I know that do some pieces of these. It's often not, and I would say, I guess, yeah, it's often also not the case that you necessarily want to think about one of these things as being the thing that you want to do. But it's the case that there's an opportunity that comes up and you realize that you actually might be the best person to do that. And it would be something kind of an interesting step for you to take in your career. And the fact that you take one of these paths doesn't mean that you're stuck kind of on one of these branching paths either. You could be a product manager RSE for some period of time, and then you might decide that you want to become a group supervisor and lead an RSE group. So I think until you actually move out of this little branching path, you're really pretty flexible to move around in it as you choose and as opportunities arise.
Cool, thank you very much for that answer. And I do agree, kind of be open and take the opportunities that come to you. So I'd like to thank Dan and also thank Matt and Naeem for some fantastic talks in this session. You've all made my, I try and pick a highlight of the day for the wrap up at the end of the week, and you've all made my job extremely difficult. So thank you very much. Got a little round of applause or some claps in the chat. It's one of the hardest things about online conferences. You can't see everybody applauding, but I'm pretty sure everyone is very much enjoyed that. So what we have tomorrow, so we have no session tomorrow morning, but tomorrow afternoon we have our discussion session, presentation session, and poster session. So the discussion will be RSE 2031, what could and should research software engineering look like 10 years from now? And that's going to be a very interesting discussion. I am in it, so I'm having to come up with ideas for this at the moment. And then that's followed by a talk, which is Voice First Research, a voice interface to research workflows, which will be showing how Alexa has been used to interface with a molecular simulation package to run molecular simulations. And I'm very much looking forward to seeing that demo. And then after that, we'll have the last of our poster sessions for what will be the penultimate day of SeptembRSE. But thank you everyone for coming, and hopefully I look forward to seeing you tomorrow. Goodbye.